Good day viewers, welcome to this channel. Today we'll be solving some problems on circle theorems. Now the first question says, from the cyclic quadrilateral MNOP shown in the diagram, find the value of x. So we're looking for this x. Now as you can see, this is a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral whose vertices touch the circumference of the circle. See, 1, 2, 3, 4. You see they touch the circumference of this circle. So this makes it a cyclic quadrilateral. And there's a cyclic quadrilateral theorem that states that opposite angles of a cyclic quadrilateral are supplementary. That means opposite angles. That means this angle plus this angle is equal to 180. So this becomes 2x plus 18 plus 84 is equal to 180. Cyclic quadrilateral. That's 2x plus 18 plus 84. That's 102 equal to 180. So 2x is equal to 180 minus 102. 2x is equal to 180 minus 102. That's 78. So divide both sides by 2. X is equal to 78 divided by 2. So x is equal to 39 degrees. 39 degrees. That's option D. Option D. Now for question number 2, so the diagram is a circle with center C. Center C. PC and SR are tangents to the circle. That's PS and SR. They are tangents to the circle. A tangent is a straight line that touches the circumference of a circle. Angle PSR is 36. PSR, that's this angle. This angle is 36. Find angle PQR, that's this angle. We are looking for this angle. Now these are tangents from external points. Now if you have a question of this magnitude, the first thing you want to do is to divide this angle. Divide this like this. Draw a line that divides this angle. So this becomes 18 degrees. We've divided it into 2, so this is 18 and this is also 18 degrees. This is 90 degrees. This is also 90 degrees. So you can use either of these triangles formed. You see a new triangle has been formed here, a new triangle has been formed here. So let's get this angle. Let's get this angle, because this angle is equal to this angle. This is a tangent and this is a chord. And there's a theorem that says that the angle which a chord makes with a tangent is equal to the angle in the alternate segment. Now the angle in the alternate segment is the angle facing the chord. So this angle is facing this chord. This angle is facing this chord. So this angle is equal to this angle. Alright, now so let's get this angle. Since this is a triangle and sum of angles in a triangle is 180, so angle PRS, that's this angle. Angle PRS is equal to 180 minus 18 plus 90. That becomes 180 minus 18 plus 90 is 108. 18 minus 108, that's 72 degrees. So 72. So if this angle is 72, automatically this also will be 72 degrees. So option D is our answer here. And for the next question, it says in the figure, FDE is a tangent to the circle ABCD at D. This FD, this is tangent, this line FDE, such that ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral because the vertices touch the circumference of the circle, the 4 vertices. So it's a cyclic quadrilateral. Now find the value of x. Now this sign means that this BD is equal to CD. This also means AB is equal to AC. This markings here, So that means there's an isosceles triangle somewhere. So let's form the isosceles triangle. To form it, let's join this line. Let's join this line. We join it like that. We join it. Now you see we form the triangle, an isosceles triangle. You see that Now, since this is a tangent, and remember from our last theorem, as our tangent theorem, alternate segment theorem, this angle is equal to this angle. The angle which a chord BD makes with a tangent, that is 50 degrees, is equal to the angle in the alternate segment. The angle in the alternate segment is the angle facing this chord. So the angle facing BD is this angle here. So this angle is equal to this. If this is 50, that means this is 50. And since this is an isosceles triangle, if this line is equal to this line, that means the angle facing this line is this, is also equal to the angle facing this line. The angle facing this line is this. This angle is facing this line here. So if this line is equal to this line, and the angle facing this line is equal to the angle facing this line, that's this. That means if this is 50, this is also 50. You get it now? Now this is a tangent. Our theorem, remember our theorem, the angle which a chord, this is a chord, the angle which this chord makes with this tangent is equal to the angle in the alternate segment. So the angle in the alternate segment is the angle facing this chord DC. The angle facing this chord is equal to the angle which this chord makes with this tangent. So if this is 50, this is also 50. So x is 50. Okay, let me run through it again. Angle BDF is equal to angle BCD. That's this angle is equal to this angle. Alternate segment. Now this angle CBD is also equal to 50 degrees. Remember this angle is 50 degrees. Angle BDF is equal to angle BC, which is 50. Angle CBD is also 50 degrees. Isosceles triangle. It's an isosceles triangle. Then X is equal to angle CBD. Alternate segment. So our answer is 50, which is equal to 50 degrees. Option B. You really need to know all these theorems. It will really guide you. So I want to suggest you go back and study all theorems related to circle. And the fourth question here says, in the diagram, O is the center of the circle. If SOQ is a diameter, SOQ is a diameter divides a circle into 2 equal halves. That means there's a semicircle. If once you have a diameter in a circle, in a particular question, that means there's a semicircle. It makes that circle a semicircle. What is the value of, look at angle PRS, that's this angle, is 38 degrees. What's the value of PSQ? PSQ, that's this angle. We are looking for this angle now. Now this angle is equal to this angle. That's angle in the same segment. They're always M-shaped or W-shaped. M-shaped or W-shaped. That's this angle always equal to this angle. This angle always equal to this angle. So this angle is equal to this angle. So this is also 38 degrees. Now angle in a semicircle is 90 degrees. Angle in a semicircle is 90 degrees. The angle in the semicircle is the angle facing the diameter. So the angle facing this diameter is this. This is the angle facing this diameter. So this is 90. Now if this is 90, this is 38, and this is a triangle. And sum of angles in a triangle is 180. So angle PSQ becomes, okay, let me first state what all I've done. Angle SQP is 38 degrees. Same segment. Angle SPQ is 90 degrees. Angle in a semicircle. So angle PSQ is equal to 180 minus 90 plus 38. That's angle in a triangle. Sum of angles in a triangle. That becomes 180 minus 128. And 180 minus 128, that's 52 degrees. Option D, 52 degrees. Then this final question, it says find PSO in the figure. Find angle PSO. PSO, that's this angle. This angle is PSO. Now, this is a triangle here. Now, angle, this PQR is a triangle. So if this 20, this 35, to get this angle, there are two methods. If I'm to do it, I won't go through that step. I'll just look for this angle. 20 plus 35, angle PRS is equal to 20 plus 35. That's exterior angle of a triangle. Exterior angle of a triangle. That's 55. Or if you don't want to go through that route, you want to go through the long route, you can subtract these two angles from 180 to get this. Or angle PRO is equal to 180 minus 20 plus 35. That's 180 minus 55. That's 125 degrees. Then since you've gotten this as 125, to get this, to get angle PRS, so angle PRS, since it's a straight line, and angle on a straight line is 180, so that becomes 180 minus 125. That's angle on a straight line. Angle on a straight line, that's 55 degrees. So instead of me going through this long process, I'll rather add these two angles to get this. Now since we've gotten this as 55, let's get this angle. So angle P, angle POS. So angle POS is twice angle PRS. That's, this angle is twice of this angle. That's angle at center. Angle at center is twice angle at circumference. So that becomes angle POS becomes 2 times 55. That's 110 degrees. So this angle is 110 degrees. Now this is a radius. Any line drawn from the center of the circle to the circumference is a radius. So this is equal to this. So that means this is an isosceles triangle. This is an isosceles triangle. Remember, we are looking for PSO. So to this angle is also equal to this angle. So to get this angle, we subtract these two angles from, we subtract this 110 from 180, then divided by 2. So angle PSO is equal to 180 minus 110 divided by 2. That's an isosceles triangle. So that becomes 180 minus 110, that's 70. So 70 divided by 2, that's 35 degrees. So our angle PSO is 35 degrees, option D. So thank you very much for sticking to this very moment. Solve this question showing on your screen. Thank you.